This is the lesson on our multi-angles for this chapter, the double and half angle formulas. What I'd like to start out with is the double angles, and I want to show you where the formulas come from. Now the word double means we're taking 2 times something. So in this case, if I look at, let's say, sine, I want 2 times an angle. Well, if I look at that 2, I could also, that 2u, I could also write it as u plus u. Now, this is not in your notes. You can write this down. I'm just showing you where the formulas come from. Applying our sum and difference formulas. Remember, for sine, it's sine, cosine, cosine, sine. So it's sine of the first angle, cosine of the second. And notice they're both u, so all the angles are going to be u, plus cosine of the first angle, sine of the second. Now if you look at what we have here, we can actually combine these and get 2 sine u, cosine u. And that is our double angle formula for sine. Oops, sorry. Let's do cosine. And I'm going to do the exact same thing. I'm going to put in, for cosine of 2u, that's going to be the cosine of u plus u. Again, applying our sum and difference. Remember, for cosine, it's cosine times cosine, sine times sine. And the sign in between the value, whether it's plus or minus, depends upon what's inside of our parentheses, and it's the opposite. So this was cosine u, so it's going to be cosine u times cosine u. This is a plus, so that means this one needs to be a minus, sine u, sine u. Again, simplifying, I end up with cosine squared of u minus sine squared u. Now this looks very similar to our Pythagorean identity of sine squared plus cosine squared equals 1. So be very careful that you're paying attention to it. It's cosine squared minus sine squared. Well, speaking of the Pythagorean identity, that means we have other things that are equal to cosine squared and sine squared. So the double angle for cosine has different versions. So the first version, I am going to put 1 minus sine squared in for cosine squared. Combine terms, I am going to get 1 minus 2 sine squared u. Okay? Alright, I'm trying to get my highlighter to work. Hold on 1 second. There we go. So we want to use this one right here. Now I'm going to go back to my cosine squared u minus sine squared u, but this time I'm going to put 1 minus cosine squared in. If I distribute this negative, that's going to give me a negative 1 and a positive cosine squared. Combine like terms, and I get 2 cosine squared u. This time minus 1. So there are 3 versions for the double angle for cosine. Which one we use depends upon what situation we have. If I have an equation, let's say, that's only got sine, I'd probably want to use 1 minus 2 sine squared u. If I'm working with an equation that has cosine, then I want the one that only uses cosine. If I've got one that's got both, I want to maybe put the first one in. So it's going to change based upon which one seems easier. Now, that doesn't mean you can't use any of them in. It just might take you a little longer to get to where you want to be. Okay? So now let's go to tangent. Now, tangent of 2u could be sine of 2u over the cosine. So we could just use basic sine over cosine of our double angles. If we already know the sine of the double angle or cosine of the double angle. Or again, we can apply the tangent of u plus u and use our formula that way, which would make it tan of u plus the tan of u over 1 minus tan u times the tangent of u. Again, simplifying, and that's going to give me 2 tangent of u over 1 minus tangent squared. Okay. So those are where our double formulas come from, or our double angle formulas come from. It's always just a good idea to be able to fall back on where these things happen, or where they came from, so to speak. Alright, let's move on to our first example. Okay, we want to calculate the exact values of sine of 2u, cosine of 2u, tangent of 2u. What we're given is the sine of u is equal to 7 over 25, and u has to be between negative pi over 2 and positive pi over 2. Now, just as a quick, I'm going to make a quick sketch just to make sure you understand which quadrants we're looking at. Negative pi over 2 is down here in the lower part of the axis. Positive is up here. The negative pi over 2 is our smaller value. This is going smaller to large. So we're going to start at the negative pi over 2, and we have to going larger is moving in a clockwise way, or counterclockwise, up here. So we need to be in one of these two quadrants. Okay? Well, looking at our value, sine of u is equal to 7 over 25, so it's positive. Well, sine's positive in the first quadrant. So I'm going to erase this pi over 2, and I'm going to actually put it over here, so it's out of the way. And I'm going to make a triangle here. And this is going to be u. Sine is opposite over hypotenuse. So now you're going to use Pythagorean theorem to find the missing side. And that's going to be 25 squared minus 7 squared. And then the square root of it. So that's 625 minus 49. Okay, pause and use your calculator to find that value. And you should have come up with 576. So our missing side is the square root of 576. So now that we have all three sides of our triangle, we can find our double angles using our double angle formulas. So let's do the sine of 2u. The formula for the sine of 2u, remember, was 2 times the sine of the angle times the cosine of the angle. Now just apply our ratios So the sine of u is 7 over 25. Cosine of u is the square root of 576 over 25. Multiply straight across. So that 2 is actually 2 over 1, so it's just 2 times 7, and that's 14 square root of 576 divided by 25 times 25, 625. That one's done. Let's move on to cosine. Now remember, we had 3 choices for cosine. And it doesn't matter which one we use. Any of them can be applied, but we were originally given sine. That one's already been calculated for us. We know those are exactly what they're supposed to be. So let's use the double angle for cosine that only uses sine. And that's 1 minus 2 sine squared u. If we'd been given cosine, we'd probably want to use 2 cosine squared u minus 1. That way we know we have exact values that were given to us, so there's less likely for us to make a mistake. Same thing, substitute in. So 1 minus 2 times sine of u is 7 over 25 squared. Square our parentheses by following order of operations. And that's going to give me 49 over 625. Same thing, just kind of start simplifying. 1 minus 2 times 49 is 98 over 625. Not 652, 625. And then make a common denominator and subtract. So 625 over 625 minus 98 over 625. Okay, use your calculator now and subtract those, or just do it off to the side. Pause your video while you do this. Okay, you should have got then 527 over 625. Okay. Now, so we found sine, now we found cosine, now we got to do tangent. Now here's the thing, we could use our tangent formula, but remember, tangent of 2u is equal to the sine of 2u over the cosine of 2u. Well, the sine of 2u is, the sine of 2u is this one. Well, that value is right here. So I'm just going to write that in. And that was the 14 times the square root of 576 divided by 625. The cosine of 2u, well, that value is right here. So that's going to go in my denominator. Now notice they both have the same denominators, both the top and the bottom. So we can cross these out and look what we're left with. 14 times the square root of 576 divided by 527, and that's our final result. It's that easy. Now the thing to remember is the fact that our denominators should be the same always if we do it this way with sine over cosine. Makes it a lot easier to simplify. Okay, let's move on to the next one. And we're going to pretty much do the same thing we just did. So the first thing we're going to do is we're going to draw our triangle. So please pause the video and draw the triangle, and then check to see that you have it in the right spot. Okay, so you should have placed your triangle in the second quadrant, because our restriction was from 0 to pi, and cosine is negative in quadrant 2. Now find the missing side. So we're going to take 9 squared minus the quantity of negative 7 squared. Make sure you put parentheses around it. So that's 81 minus 49, and that would come out to be 32. Okay, so our missing side is the square root of 32. Now we just do exactly the same thing we just did in the previous problem. Now we find the sine of 2u by applying our formula of 2 sine u cosine u. So please pause the video, substitute in your ratios, and simplify, and then check your answer back when you come back. Okay, once you applied your ratios, you should have simplified it to be negative 14 root 32 over 81. Okay, let's move on to the cosine of 2u. So we were originally given cosine, so we want to use the 2 cosine squared u minus 1 formula. Again, pause your video, do the problem, and then come back to check your work. Okay, hopefully you got 17 over 81. Let's move on to our tangent, and we're just going to do exactly the same thing we did before because we've already calculated sine, we've already calculated cosine. So the tangent of 2u is just sine over cosine which equals negative 14 root 32 over 81 divided by 17 over 81. Again, our denominators match, so we can cross them out. And we're left with negative 14 root 32 divided by 17. Okay? Alright, so that's where we're finding our values of our double angles. Let's move on to our next example. And now we're going to be solving an equation. So now the first thing is normally what we had in the past when we had like the 2x, we solved for it and then just divided everything by 2. But because we have this cosine right here, that's not going to work because we're not going to be able to have a 2x and an x. It's like having two different variables going on. So we need to get them all to be just x's. Well, I have the sine of 2x there, so I'm going to substitute in my formula for the double angle for sine. So this is 2 times the sine. Oh, hold on, let me start over. 2 times the cosine of x plus 2 sine x cosine x equals 0. Now we just solve it like we did in the last unit. So I have a common factor of 2 cosine in both terms. So I'm going to factor that out. That's going to leave me 1 plus the sine of x equals 0. Apply our zero product property. Now solve for x. So the cosine of x would be 0. Well, that would be at the pi over 2 and 3 pi over 2. And sine of x equals negative 1. Well, that's at 3 pi over 2. So they actually have two of the same solutions, which is going to make it easy because if we graph this, pi over 2 is here, 3 pi over 2 is here, so they're same distance apart, so we can wrap our solutions to be x equals pi over 2 plus or minus pi n. Because they match at 3 pi over 2, we don't have to write another equation. Okay, so that one wasn't too bad. Okay. Now, if we had had the cosine of 2x in this problem, we again would like to do what we did earlier. We have to choose which one we want to work with. So you have to be very careful. Like since this had a cosine, I'd probably use the 2 cosine squared minus 1 identity. If we we had sine, I'd probably want to use the 2 sine, 1 minus the 2 sine squared. So the cosine squared gives you options to help you solve your equations. Okay, let's move on to the next one. Now we have a proof. Okay. So there's a couple of things we can do. And we can either start with the left side or start with the right side. I'm going to start with the right side. Now the thing to remember is we always want to keep looking at that other side to see if we're getting there. Cosecant is the reciprocal of sine, so we are actually looking for 1 over sine of 2 theta. So let's keep that in mind. We're looking for 1 over sine of 2 theta. So cosecant could be written as 1 over sine divided by 2 times the cosine of theta. Well, I can simplify the right side. Remember pretending that this one is over 1. So we're really just dividing fractions. So we have 1 over sine of theta times 1 over 2 cosine theta. Combine our two fractions, we get 1 over 2 sine theta cosine theta. Well, right there, that's our double angle for sine. So do our cosecant of 2 theta is equal to 1 over the sine of 2 theta, and then flip it over to make it a cosecant. And there's our proof. Alright, let's go on to the last one for today. And we're going to go on to what's called the double angles. I think I just said double angles, and I'm sorry, I meant to say half angles. And so if you look at your half angle formulas in your notes, there's square roots with them, and there's plus and minuses in front. So let me write these on here real quick. So the sine of theta divided by 2 equals plus or minus the square root of 1 minus the cosine of theta over 2. Cosine of theta divided by 2 equals plus or minus the square root of 1 plus cosine of theta divided by 2. Now, these plus and minuses right here, guys, you're not having two answers. Your final answer will be positive or negative. It can't be both, depending upon what quadrant theta over 2 is. And I'll show you how to figure that out. So completely ignore the plus and minuses until the very last step. Okay? Now tangent is the same as it always is. Tangent of theta divided by 2 could be sine of theta divided by 2 over the cosine of theta divided by 2. That's one thing. Or you could have 1 minus cosine of theta over the sine of theta. Or it has a third option. The sine of theta over 1 plus cosine theta. Okay? So let's do our half angles. Now half angles aren't used that often, but they are used. So you do need to know them. Need to know how to find them. So we're going to calculate the exact values. Of sine of theta divided by 2, cosine of theta divided by 2, and tangent of theta divided by 2. Given, and I'm going to go over here to the side, given that the cosine of theta equals 5 over 13, and we know that theta is between pi and 2 pi. Okay? So we're going to be basically dealing with theta through all of this. Again, the plus and minuses don't come in for the theta or the half angle until the very, very end. So let's start calculating. Again, we're going to make a triangle, so pause your video to make your triangle. You should have placed your triangle in the fourth quadrant because we were going from pi to 2 pi. So this, remember, pi is the smaller value. 2 pi is going to be the larger. So moving counterclockwise from pi to 2 pi. So we're looking in this section over here. Okay? So our triangle is in the fourth quadrant, which makes that 12 a negative. So don't forget the 12 be a negative. It's important. So let's find the sine of our half angle. I'm going to leave a little space next to the equal sign to either put a plus sign or a negative. Again, like I said, we're doing at the end. So we're going to do our square root, and the sign is 1 minus the cosine of theta divided by 2. So that's going to be the square root of 1 minus the cosine of ours is 5 over 12 divided by 2. Now we need to do a common denominator. And I know how you guys don't like doing these common denominators, but it's important. So that's going to become, I'm not going to put it there, (12 over 12 minus 5 over 12 divided by 2. I'm going to clean up my square root a little bit here. Make sure it goes all the way down. That's going to give me the square root of 7 divided by 12. All of that's divided by 2. Now if we simplify that a little bit, that's going to give me the square root of 7 over 24. Remembering that if I have, remember if we had like 1/2 divided by 3, you guys tell me it's 1/6. It's the same idea. Same idea with us. So you just multiply the two denominators together. Now is where we decide where our angle is. We could do cosine too, but let's just do it right now. So I know that theta is between pi and 2 pi. So to find theta divided by 2, I'm going to divide all of these by 2. Divide our restriction by 2. And that puts us at pi over 2 is less than or equal to theta divided by 2, less than or equal to pi. What quadrant's this? Hopefully you said the second quadrant. So that means that theta over 2 is in our second quadrant, which makes cosine negative and sine positive. So this was the sine that we found, so this one's going to be positive. Now let's do our cosine. And this is going to go a lot faster because the only difference between the sine of our half angle and the cosine of our half angle is that there's a plus sign now inside of it. So the cosine of theta divided by 2 equals the square root of 1 plus the cosine of theta divided by 2. Now I could start all the way back up and put 5 over 12 in there, but why don't I start where we had our common denominators? Ooh, that's a really bad. Hold on here. Why don't I start right here and put a plus sign in its place? I've already got common denominators and I can just combine them. I keep wanting to do red, I'm sorry. So now I'm going to have 12 over 12 plus 5 over 12, all divided by 2. That's going to give me the square root of 17 over 12 divided by 2, which is the square root of 17 over 24. Now, again, this is where we decide whether we're going to have positive or negative. Our half angle is in the second quadrant. Cosine is negative in that quadrant, so our answer needs to be a negative. Okay? Now let's do tangent. Now here's the thing. We could do the tangent of sine over cosine, but that's going to put square roots over square roots. And some of you may not be comfortable with that. And that's okay. So we could do this. The tangent of theta divided by 2 is the sine of theta divided by 2 over the cosine. When I type. Well, sine is the square root of 7 over 24. The cosine is negative square root of 17 over 24. Now, if you remember anything about your square roots, if there's a square root on top of each other, you can rewrite it as one big one, like this. Now that's positive over negative, so our answer is going to be negative. Cross off the 24s because they're the same denominator, and we get the negative square root of 7 over 17. That's one way to do it. But if you don't feel comfortable with the square roots, pick one of the other ones. We can do 1 minus cosine theta divided by sine, or we could do sine over 1 plus cosine or theta. It doesn't matter. I would probably do the 1 minus cosine over sine. Okay? But again, it's up to you. Well, we already know that 1 minus cosine, if we go back to our sine, 1 minus cosine is right here. So we could just put that in. 1 minus 5/12. The sine, if we look at our original function, the sine is negative 12. Hold on. Did I use 12? I am so sorry. I just realized I did this problem wrong. Should have been 13. Okay. Alright, so I'm going to go back and I'm going to change all those 12s to 13s. Again, I am sorry that I just caught this mistake. Okay? But everything else that I've said is correct. So that 5 over, so if we go back to the sine of our half angle, that 5 over 12 actually should have been a 5 over 13, which changes our 13 over 13 that we had, 12 over 12 to a 13 over 13, which then changes the 7 to an 8 over 26. And you don't have to reduce it if you want to. You can. So you could say it's the square root of 4 over 13. Okay, now for the other one. Same thing, but now it's going to be okay, so we got to change it here. Okay. Final answer is the square root of 4 over 13. Okay, now let's do our cosine. And again, I am sorry, I just caught this mistake. I'm going to change that to be 13 over 13 minus the 5 over 13. that's going to make it, or excuse me, it should be plus. That's going to make it then 18 over the 26, and that reduces to be 9 over 13. Go to our tangent, change our fractions. So I'm going to erase the work that I've got here, and I'm just going to start over. Like I said, I'm sorry about this. The sine of our half angle ended up being the square root of 4 over 13. The cosine of our half angle was negative square root of 9 over 13. Again, we can make this a big square root, and it's 4 over 13 divided by 9 over 13. 13s are going to cancel, and I'm going to end up with the square root of 4 over 9. Well, that's a perfect square, and so our answer is 2 over 3. Going down to use the other formula. So 1 minus 5 over 13 divided by the sine, which would be negative 12 over 13. And I forgot to bring a negative here. Common denominator is going to make that 13 over 13 minus 5 over 13 divided by the negative 12 over 13. So that gives me 8 divided by 13 over negative 12 divided by 13. 13's cancel as always, and that's negative 8 over 12, which reduces to be negative 2 over 3. Notice they match, and that's what they're supposed to do. Again, I'm sorry on this last problem that I looked at the triangle wrong and didn't catch it till the very end. But that's our half angles. The big thing is making sure you do that restriction and dividing it by 2 to figure out where your half angle is to get your sines. Alright, start your assignment right now, and I will be back on Wednesday if you have any questions.